Hello, everyone, and welcome to today's tech session. We are building on a really great discussion that we previously had on, which was a deep dive into recommender systems. And today, Ramsey is going to take us through how you can actually build one that works on our prediction platform. He's going to take us through the Workbench, looking specifically at a basic static recommender workflow and things like data preparation and generating recommendations. So thank you to everyone joining today. And Ramsey, over to you.
Thank you very much, Madison. Just get my slideshow. I'm always confused with Google Slides to get it to start. Go into slideshow mode. Yes, hi. As Madison said, we're going to be taking a technical look at how to build and configure static recommenders in the ecosystem environment. Due to previous technical meetups which focused on specific parts, we're going to be glancing over things like feature engineering, data prep, and use case design, since those are covered in detail in previous cases. But this is going to be more about showing how you can quickly and effectively build recommenders, specifically static recommenders, in the ecosystem environment and iterate on the kind of development process, which is very useful because you build the first one, it might have certain good points, certain bad points, but you can then very quickly iterate and hone in on the specifics that you want to, depending on your use case. So it's just going to be a quick overview to show you all the steps that you need to take into account when you are building a recommendation. So as you go from the left, first is your project definition. This is where you design your use case, decide what you want to use internally, what metrics you are trying to push, what message are you trying to recommend, what product are you trying to recommend, all comes kind of down in there. Next step is going to be getting data. So there's kind of two methods to this. One is to directly ingest raw files. This is usually the easiest way when you want to start prototyping, but once you get into productionizing, you're usually connecting directly to data sources. This is easily done via Presto, which is kind of a data virtualization platform, which allows you to, through a single interface, connect to any data source imaginable. Once you're going to have your data in the system, you're going to be enriching it, doing some feature engineering on it, making sure your data is clean. There's no useless columns, that all the format is in the way that you want, and that the dimensions of your data is in the way that you want it. That's kind of all sits in there. But like I said before, we've already done a lot of talks about this. The next is going to be your feature stores. This is essentially the process of ingesting your data into a format that your models can access or use effectively. After that, you can have the prediction stage. This is where you are designing your predictors, your recommender, building a static recommender, deciding which fields that you want to use, how many models, which hyperparameters you want to tweak for your particular models. This is going to be the part where you play around a lot and turn all those knobs until you get the best possible result. The next part is going to be deployment. Once you have the model that you are interested in putting into production, how do you actually serve it to a customer or to a client in the deployment stage? And then you have your testing. This is where you get to a more iterative section. This is where you're going to see if your models are performing the way you want them to. If they're not, go back to step one, either rethink your use case or make sure your data is as clean as you think it was, or play a bit around more with your feature engineering or tweak some of the hyperparameters. There's multiple places where you can tweak those buttons, and kind of monitoring at the end, which is similar to testing, but it's more just looking at the wide scale of your data as you run your models at high volumes to see what the convergence stuff that looks like, to see that it is not overly biased towards any particular outcome and things like that. Sorry, what I forgot to mention at the front end is we're also going to do a dual look. We're focusing on how to do this whole process through the Workbench, which is our graphical user interface into the ecosystem. But at the same time, since we have a worker-based architecture, you can run all of the functionality of the Workbench is available through APIs, and you can run it entirely through a code environment as well. So I'll be kind of dual showcasing the Workbench environment and how you can perform the same tasks via Python wrappers in the Jupyter Notebook environment. So that's it for the slides. So I'm going to go straight into the Workbench. So as we said before, we can start off with the project definition. Let's do it like that. Then you get to our Workbench. See there's a bunch of buttons here on the left. We can go first to projects and define our grouping for ease of use. Define these things beforehand and then show the fields that you can fill in. Setting up your project, you can click on it. There's a bunch of fields. The key value you're going to define here is just going to be your project ID. This is the key ID that's going to be used going forward to refer to this use case that you're designing. You can specify a lot of useful information for any future colleague that's going to be looking at this use case to make sure they understand what it is. You can give a lot of information around descriptions, like the short description, the long description. There's a lot of additional information here. You can tag images, fact sheets, additional tagging that you can do to ensure that everybody knows is on the same page and knows that this use case is going to perform a particular, because most of this is just logging. It's not going to be necessary for functionality. It's just for referencing. You basically just specify these, you can click it, you can export it. There's a lot of things you can do around here. But for now, we're just going to be saving it. And now we have our project set up. Preview, it's going to be very straightforward. As I mentioned before, we have some wrappers associated with our API endpoints. This is freely available on PyPy, so you can use pip to install these wrappers and use it locally. Basically, this is what the import is going to look like. You need to have a working ecosystem server. So you can't just install the wrappers and then run it. You need to have a working server that you can point to. And once you have a server that you can point to, you just specify username and password using some very generic default password here. And then there's multiple functions you can use to kind of have a look at your projects. First one over here is just going to be having a look at all your projects. So it basically just like gets all the prediction projects, gives you all information and what that actually going to look like in the JSON format that you get it back as. Is basically going to be looking like this. You're going to get this value back. You can then parse all the relevant information that you want to look at that point, read there. And on the flip side, if you just don't want to just look at the project, but you want to add a project, it's going to be the same. Just generate this JSON payload for the fields and flags tag that you want to, and run the save prediction call. What's important to note is we'll usually find that in the development cycle for prototyping, we'll usually end up using the Workbench first. Once you get a good idea and feel for what you want to do, then you will, and you want to kind of start productionizing it and getting this to run automatically through some pipeline software like Airflow. But you're going to start adding a code line into it and automating it. So you can then have all the steps prepped, automated to the specifications that you like. So that's why we're focusing on both at the same time. After you have your project set up and make sure that all your docs are filled in correctly, you now have your environment set up and you can start thinking about what it involves. Let's go back to we talked about you need to get your data in and do some feature engineering. I'm just going to show that we have some data ingested already that has been feature engineered. So how do we look at that? Let's go find our data. We have our data stored under data and features and then feature engineering. We have our data set up here, demo static recommender data. And in here, we just have some training data that looks something like this. So this is just some generic generated data that we are going to be using. This is not realistic customer data, but it's useful for showing the process. Essentially, we have some generic information about a customer, their gender, level of education, unique ID, whether they're on property or not. I think this was simulated off the banking data. So this is some information about that might be relevant to banking. Then we see some enriched data here around the date of birth of this individual. It's taking all of the date of birth fields and kind of giving you all the permutations that you might potentially want to use for modeling. You can see here, it's like the hour, date of birth, year, week combination, time of day, these things. And then some more things like bank accounts, marital status, whatnot. So this is now data that's been through the process, it's been cleaned, it's been prepped, it's been feature engineered. We're just skipping over that whole step. But if you want to do something similar in the coding environment, it's just kind of, I'm not going to just going to gloss over it a bit, but basically, yeah, you can upload files directly, can do some commands here to make sure that you're connecting to outside sources to pull data in, can import data into Mongo collection. So internally, we use MongoDB as our feature store. This process is importing a CSV file and converting it into a Mongo store. The next step on our journey to think about feature stores. This is the process by which you kind of prep your data to be usable by your modeling software. So in this case, we are going to jump over here. So we have this whole environment where you go here, static models, feature stores. Maybe just show the previous page first. So you're gonna call this thing demo static, which just like select your feature engineering ones you're interested in. And over here, we are going to be ingesting our data. As the feature store generator requires the data to be in a raw file format. So you'll usually see the process is you'll ingest data into a Mongo environment, do all the feature enrichment you want to, export it back out into either a JSON or a CSV file, and then ingest it back into the kind of X format that is necessary for model training. Where you're specifying how you want to consume the data. Once you have all that set up, you can press this check data button. It will show you all the fields and the assumed data types of those fields. Done properly, a lot of these assumptions might be wrong. You can manually change them over here. So you can say this is numeric UID string, whatever. It's important, especially if you think particular features are going to be of high importance, that you make sure that the data types there are right. And there's also particular cases you'll see with IDs, especially if the IDs don't have like dashes or the characters in them or it's numerical. So just straight numerical IDs that they will a lot of times be assumed to be numerical data, but you want to use them as categorical data. So you need to force them to be enumerators. So the enum value here. Essentially, you just decide what your field data means and how to use it, and just specify them all there. Once you have that done, you come over here, click the parse data, and then we'll see at the bottom, this is previously parsed data, but we will then have, what was this thing called? Backwards managed 10 hex. This is what we wanted to write it out as. We have this here, that's great. You can also, just for some convenience, there's a split tool here. If you want to split up your data into training and validation sets, you can do that. Show you what that looks like. This is some artifacts sitting as before, but then we'll see over here we have our 020, 080. So this is a 2080 split. So this will be our validation set and our training set. It's split pretty randomly. So if you have any ordering in your data, it won't be a problem, because usually if you're sampling from a ordered set, will not be very useful, or it can be bad depending on what type of data you have in it. But the split call here does automatically sample, so it should give you a good distribution of data in both the validation and the training sets. How would that look like in the Python environment? So here, essentially, you're going to be duplicating all of the values that you have. But first up, we're exporting a value document here. This is our trained or enriched feature data before exporting to a CSV. Once it's exported, we can then create our feature store. Over here, the same that we have at the top here, where we set up our different data types. You can specify all of your different columns and the types. Once done, you just call this save as user frame, and it will generate that. In this example, I have the split functionality. There's an omission, but there's very much all of the functionality you can do in the Workbench. There is an API for that in the backend. So it's a case of having to know what you want to do and how you can do it. So next up in our process, now we have our feature store set up. So we want to build our predictor. So our prediction process, we come into static models, model training. You can look at all your previously set up model training environments. So here is going to be a few things you're going to set up. Two of the important ones are going to be a predict ID and your model ID. So predict ID is just the name of the prediction environment. So this is basically saving all the metadata related to training the model. The model ID is the name of the specific model or model process that you're kicking off. So in this case, we're going to be using H2O's AutoML process. This essentially generates, kind of does the shotgun spaghetti against the wall process approach, where it just generates a few different types of models and kind of just compares them using the sorting metric of your choice, and kind of gives you them in order, and you can just select the one that usually has the best score. If that score is high enough and it's doing it in the way you want. So that's going to be an internal kind of H2O ID. But granted, we are not only limited to H2O, we also have integration into PyTorch and TensorFlow, and there's another one I can't remember now, but you can also, there's a bunch of other model types you can set up. As you can see here, some of them are straight up category recommender stuff, but then you have some clustering models in here and some internal or custom models that we have set up for personality and sentiment stuff. But this is just going to be showing us more the process of setting up the models than the specifics of hypertuning and selecting model types and things like that. So once you have your model type selected, you can click generate default. This will, depending on the model type you selected, it will generate the hyperparameter setup for you and populate it with kind of default values. This one now that I have here has been tweaked slightly just to get the specifics that we are interested in. So I have to basically the big changes I just made here is specify the training and validation frame using the same names that I generated before when I used the split command, saying that the validation frame is going to use the 20% one and the training frame is going to use the 80% one. Then I'm specifying a response column as well. So in this case, we're just using that customer data or training data we had before about banking customers and trying to see, can we build a model that is going to use all of the features that we have in there to determine their level of education. This is not a particularly useful model, but it is useful for demonstrating the process. A lot of hyperparameters in here. You'll see there's max models, so you can specify how many models you want this AutoML process to train. There's stopping tolerances, multiple ways you can stop this process. So it will try and get to the end unless certain stopping tolerances are hit. There are multiple stopping places here. Can it train all of your models that you have specified to the stopping tolerances that you have specified? Each iteration of the models can get better within a certain parameter. You set if your stopping tolerances here, it will then stop. You can see we're stopping around here as well. This one will do 10 iterations on each model. If the iteration doesn't get better at this percentage, then it will stop. If it doesn't complete this whole process within 3,600 seconds, which is an hour, I believe, it will stop as well. If you're looking at sort metric here, like I mentioned before, we have the AutoML will rank the performance of all the models generated. You can select the kind of metric that you want to. So you can use AOC or MRSE or whatever, a bunch of them. Let's pick the default one over here, just using log loss. Yeah, there's some stopping metric over here is auto, so you can change that to something specific you want to. You can decide you want to balance the classes, you want to keep in cross-validation, bunch of things, you want to do in-fold stuff. Not going to go into deep into this because this is kind of Mongo specific stuff. If you want to know more about this, you can read up on this on Mongo's sites and their documentation. We are just using their software. But the important case thing that we're looking at here is our exclude algos and our ignored columns. So this is empty now, but before it had a bunch of, let me maybe just for explanation to show this. I just generated default again now. So I just removed all of the configs I made. Essentially, this thing is going to be trying to build, there's 6 model types that it will try to build: GLM, Current, GBM, DRF, XGBoost, and Stacked Ensemble. But you can either use include algos or exclude algos, depending on how you want to do it. We just kind of like the blacklisting instead of the whitelisting. So we are saying, if you run this now, it's not going to do anything because it's not going to train any models. But if you say, okay, in this case, I want to put this in JSON view, so I can actually remove this. I want to build models that are XGBoost and GLM. If I run it now, it will train on those 2 models. So you can just select the ones that you're interested in. Take all of them out and train on all of them. Same thing we have with the ignored columns. This is now where you're going to have to be certain of your use case or your feature engineering and things like that. So this is basically where you want to select the features to be used by the model. Certain things are generally not useful. Things like the key ID. There's no predictive information in a customer ID, so you don't need that in there. Like the customer's name, unless you want to try and determine race or nationality or geographic location by trying to do some name matching. But then again, that's going to be an enriched feature and it's not going to be the name by itself. So the name by itself is going to be useless. Same with email address. You might have enriched it to look at the domain. Maybe the domain has some information in it that you think might be useful. Yeah, so it's going to be basically things like this, like remove what you want to remove and use the thing that you want to use. Once you have that set up, I'm just going to close this again because I haven't saved it. So I'm just going to get back the data that I do have in there. Once you have that, you will then click the generate model button. This will then kick off your H2O modeling process. Depending on the size of your training data and the complexity of it, this can take very long or very short, but this is a very small, I think it's just 10,000 records. So it's a very small example, so it goes very quickly. Once you've generated it, you can just click the results button. It will show you the progress. It's going to show a lot more now because it has some of the old logs that I used before for this particular use case. So I can just click to the end. I can see it's busy training this GBM model now. And just wait for it to finish up. Another way, I can just check all the models I have. This thing is going to train 10 models, and I have 3 models trained already. I had, I think, 40 trained before, so it's done 3 of the latest ones already. I can just click the results button again. get the latest results. Yeah, it looks like it trained all of them. Let's go to the end. Should really be an end button here. And we can say, okay, cool, this whole process took 60 seconds. So it's nice and quick, all 10 models for us. Now we have built all of them, like I mentioned before. You can see here all of the models that we have trained before. We are internally looking at the means per class error in the ACU, so you can kind of see which one you're interested in by saying this here, and the curve looks nice, so let's take that model. If you're interested in a particular model, you can save it. It will then pop up over here. Should pop over here, but just need to refresh it. That XRT one I just created is saved over here. I did not want to click that, but you can look at some of those values. I have another one I will show because I have spent before, but you can either deploy it. The deploy is important. Once you train your models and you kind of had a look at what they perform like, you can then deploy it to make it widely available to the ecosystem environment. Otherwise, it's just sitting in the storage environment. Or alternatively, you can delete it, or you can test the model to do a quick check. But since I was in this process now, let's just go over here. This is the model I had before. This is going to be one of your iterative processes where you want to make sure that your models are performing right, that your variables are set up right, that the feature importance is looking okay, nothing is overscaled. It's a nice view into this. You can see over here our feature importances, scaling for this demo data set. Day of the year seems to be quite important. Also the year, number of bank accounts, whether or not your own property, month you're born in, whether you're married, and your gender. And remember, we're trying to predict the level of education of this customer. If you want to look at the same data in a more numeric format, the table is down here. There's some training log loss stuff over here you can look at and see all the trees and how the log loss kind of drop down there. You can look at our confusion matrices. You see this model is doing relatively, it's getting about 400 associated trees and about 100 for all the other ones. So it's not a perfect model, but it's better than random. Look at our cross-validation matrix. Not very good. There's a lot of information you can do in here, and if you are not happy with the result, you can then go back and redo your use case, design your feature engineering, try and generate some more features, remove features you're not interested in, or that have been shown to have do not have any predictive capabilities, or make sure your data is properly clean. Again, a lot of steps you can take, tweak your hyperparameters of your modeling, go through that whole process. If you are happy with your data at this point, the next step, sorry, before we get to that, let's just talk about the equivalent of it in the Python environment. First up, you can look at all the predictions. Once again, the prediction is this environment that we set up, basically all the information, the hyperparameters and the logs associated with that. So you can look at the individual prediction projects. In this case, it's showing all the project IDs. If you're actually splitting the frame, this is how you can split your X frames if you want to. This is looking at your predictions. If you want to create a prediction from scratch, you can do the same. So this is basically a JSON format with all the same data we said before. It's just showing how to set up I think this is also, yeah, it's a AutoML H2O algorithm, all that program to set up. Once you have it, parameters save the prediction and train that prediction. Once that's done, you can download the model mojo that is going to show you that kind of leaderboard with all the model IDs attached. You can select the individual models that you're interested in and save them to disk. So next up, we want to deploy this and start testing it. To get this in deployment, we need to set up a runtime configuration for this model. How we go about that is we go to our deployments page. Once in there, you select your, let me just show specific deployment. This is our project deployment, and we can start configuring here. These deployments are very flexible, so there's a lot of specific functionality that you can add or remove from here. But since we are just setting up a very basic static recommender, just to show the process, I'm going to take you through that. Just setting up our prediction case ID. You can do it like with the projects, descriptions, types, purposes, and the version as well. You'll see we have this environment status. You can also set whether you are in an experimental phase, whether you're testing a production phase. While this might seem just like a logging, it does have some actual functionality, which I'll get to later in the config. This is going to be our key point. This is all the kind of features that you want to associate, or functionality that you want to associate to your deployment. So in this case, since we're doing a static recommender, we need to set up the prediction model to link it to our saved model file. Then we're doing parameters from data source. This is going to be our customer lookup. So we can then use a customer ID and get all the scoring data required to score against the model. Then we have our plugins. Plugins is where you're going to set up your pre and post scoring effects. So anything you want to happen before or after the actual model gets scored. For pre-scoring, it will be tweaking or changing the data to work with the model you're using. The post-score is going to be editing or changing the data after the scoring has happened. In this case, we set up the plugins because we are building a categorization recommender here. It's going to be giving us not a score, so we just need to set it to multi-classifier format. It tweaks the outputs, so it produces an output JSON when you call the scoring that is in a format that you'd expect it to be. I'm not going to take on any of the other functionality. So you'll see once, if you click on any of these, you'll see the drop-down windows for these things as you go. I'll briefly talk about these other sections. These build and path settings is going to be useful for when you are setting up a build environment via something like Jenkins. So you can set up an environment and you can build this, or if you want to build a containerized version of this runtime, which is useful. The alternative method is to have a runtime already existing and you can push the configuration into that runtime. Since this is just going to be our experimental proof of concept environment, we're not going to be building anything, we're just going to be pushing it to an existing kind of dev runtime. So we won't be focusing too much on the build and path settings. Then you have the database settings. This is going to be important since this is telling the runtime that we are pushing the config to, essentially how and where to access data from the main server. It's provided with the connection string to the MongoDB and kind of tell it where the logging databases or different logging stuff sits for the environment. And then you'll see we have these three fields that are just going to look very similar to the ones we have up here. Essentially, this is a quick swap between different runtimes, if you want to say it like this. But since we're just using the scoring one, we're telling it this is the IP where our runtime is sitting. Since this is all being hosted in the same space, we are using aliasing to access the runtimes. You can't use this URL outside the environment. It's just internal kind of Docker aliasing, so the different services can talk to each other. JSON, as we've seen before, is just going to show all of the information we have here in JSON format. So we're going to look at our specifics that we set up here. We have our prediction model. This is where we specify our model. In this case, we're just using our H2O model. You can see examples. We use different models for different modeling technology, recommendation technology like TensorFlow and PyTorch. But the default one we use is H2O. So you just specify the name of the model to be trained. Very straightforward, nothing complicated in there. So you have to set up the customer lookup that we want to use. So we're telling it use MongoDB, using an internal one. We don't want to use an external customer lookup. We're telling it the database and collection to look from. And then our key field here is going to be where our kind of key ID is. In this case, it's a customer number, some kind of ID number. Then we can specify the type in here. In this case, we're just numeric. So you can see here if you want to, it doesn't have to be 1, 2, 3. You can type in any number just to tell it like, this is the type of data I'm interested in, numeric data. And then you're telling it all of the fields that you want to actually push into the model. So essentially, you load up your data, you can just click the validate button, it will auto-populate these fields for you if you want to, and you can remove things if you want to. Just removing this underscore ID, that's an internal Mongo ID that we're not interested in. That's why that's the underscore in the front. There's some additional things you can do here. I'm not going to get deep into because it's for some advanced functionality. It's not useful. But I'm not going to be using for this test case. And then, like I said before, we're going to be setting up our post score over here to be the post score recommender since we're using a multi-classifier. It shows you some code. This is the default post score recommender, but this is also a place where you can inject any code you want to. You can add in some generic Java in here, and I'm not going to be typing anything because I'm not 100% fluid in Java. You can add any changes in here as long as the functionality makes sense. If you want to then save it, you just click compile and it will immediately create a compiled version of that Java file that you can then use with the runtime. So once all of this is done, you just click update to save it. And then since we're not generating a building, so that's for the more late stage productionization, you can push this to the runtime. So this process is now connecting to our runtime and setting up all the configurations on there. It's now deployed. So let's see what that looks like in Python. Once again, you can get this prediction project. So like I mentioned, the project and the deployments are tightly coupled. This is why we are getting this prediction project. If you go back here, if you look at the JSON, it actually gives you all the information for the project as well. So this deployment step is where all the data we have in here now that we're seeing, but the data at the top level is the project data. So that's why we're getting prediction projects, and then we can step through the deployment steps if we want to find the one we're interested in. And have a look at them. You can also create it from scratch. See, this is a very arduous and weighty JSON file here, but it's just going to be adding all the information for the UI in here. And once you're happy with the one that you want to do, you can just either create a new one, or in this case, we're just editing one that exists already. So it just gets one, does a small change, and then saves it back using this kind of save prediction project. Very easy. And then once you kind of have it set up, you can kind of do a generate build or process a build or process a push. This is replicating the same functionality that you have by pressing these buttons, generating a build, pushing a build, or kicking off a build, pushing a configuration to a runtime. So now we had a push, we want to actually see if this runtime is doing the job it's supposed to. The easiest way to look at that is to go to our laboratory space, look at manage APIs. Here we have a setup where you can look at some calls triggering the runtime. So this is setting up API calls to the runtime. The one thing looking at here is the offer recommendations endpoint. We have to specify for login reasons. We have to specify the campaign name. So this is what it's going to be tracked as in the back end. You can also specify sub-campaign for additional tracking. Lookup is the key value. This needs to be a valid key ID specified in the customer lookup we set up on the deployment before. Channel is just additional logging. It's just to track what channel you're coming through, and number of responses going to tell the model how many responses to return. So if you're telling it to return 10 responses, it's going to show you the 10 base responses for the parameters that this customer has, and then just user tracking as well, just using the ecosystem. And then you can add in additional parameters such as contextual variables that certain cases will use. In this case, we're not using them, so you are just keeping it blank. If you then click on this one and run it, you'll see that we get a long result, but the one they're interested in is just this offer starting with this customer 1006. We think they are a doctorate level education. Great stuff. Do the same in the Python environment. Once you have it pushed, you can set up a runtime over here. You have to specify the URL for the runtime, and that's going to be the same as the one we pushed to. Connecting to the runtime, specifying the values that you're interested in, and you will get a value back. That is how you get a recommendation or a text recommendation. You can now see that this thing seems to be working. It's doing something. You can play around a bit with the different customer IDs, see what they look like. If you want to do it in bulk, an easy way to do that will be to run a simulation. But before we get to that, let's look at our monitoring side of it. So we have internal monitoring system that we use is Grafana. Grafana is good for time-based interaction kind of data. We also have more standard dashboarding. Most of this stuff is boilerplate to show how you would potentially look at the data, but most corporates usually end up using their own dashboarding software to view the data in ways they are comfortable with reading it. So we use this more as just examples of how you would look at the data, but we can then look for static recommended demos, the one I used for the last 5 minutes. Let's refresh this, and we can see this doctorate recommendation we made popped up here. This is very boring. Let's go see what it looks like to do this at volume. So simulation. After manage APIs, you have simulations. You can come here and set up a simulation from scratch. You come here, set up some things. You have to attach it to a particular deployment. It's just going to be the same one that we set up before, and you can set up particular runs. You want key values. You want to be interested in this number of iterations. It's just how many times it's going to call the recommender and give it a default take-up rate. You can get more fancy if this is to have specific take-up rates for specific customers, of specific groupings of customers. You have to create a file for that. So I can look at it up. In this case, just 10% of the customers are going to decide to take up an offer. Specify what happened to the client pulse responder. It needs to be in here. But once we have that set up, we can take the run button, generate 1,000 of these. It's going to be relatively lightning fast since this is a very low weight. We can see all of these iterations coming through, all these recommendations coming through, or what the recommender thinks these particular customers' level of education is. And you can see it's leaning a bit towards no formal education. Associate degree is one of the least popular ones. Okay, it seems to have stopped now, since this seems to be about 1,000. It's about 1,000. And I can just check here. That's the one that I did before. And then we have our 10%. Important though that 10% is not forcing it to be 10%. It's going for each case, it's just rolling the dice, and if it's a 1 in 10 chance that it's going to accept it or not. So it's not taking 10% of the sample and saying they must accept it. So that's why it's not going to be perfect. It might be slightly higher, slightly lower, depending on your luck there. There's no Python version of the visualization here, since it's just this. But once you get to this point and something seems hinky, some offer is getting over-recommended, that's now where you're going to go back to your flow and make sure everything is working the way it should. I think I completed this just, yeah, that's pretty much it. I know this glossed over a lot of things, but this was more a demonstration of how you set up process in ecosystem. And sure, this took an hour now, but once you are practiced, you can set up a recommender in like 5 minutes. That speed to productionization and the ability to iterate really quickly and just push new configurations, making small changes, pushing it again, checking the results, seeing it is incredibly useful. It's incredibly, which makes you incredibly flexible to do a lot of A/B testing quickly and just have a crazy idea that you're not sure if it's going to work. Just test it quickly. You might find something unusual. I think that's about it. The end. Thank you, everybody, for humoring me as we talk about this process.
Thank you so much, Ramsey, for that.